All right, guys, Mr. Antonucci here, and we're in section 6B, confidence intervals for a population proportion. And in this video, we're actually going to break this section into two videos, but for both of them all together, we're going to cover these learning targets, check the conditions for calculating a confidence interval for a population proportion, calculate a confidence interval for a population proportion, construct and interpret a one sample Z interval for a proportion. We'll cover those three targets in this video. And then in the second video, we're going to describe how the sample size and confidence level affect the margin of error and determine the sample size required to obtain a confidence interval for a population proportion with a specified margin of error. Okay, so before we actually calculate a confidence interval for a population proportion, we need to verify that some conditions are met so that we can be able to use the calculations. So the conditions for calculating a confidence interval for a population proportion, there's basically three of them. Random, you want to make sure that the data come from a random sample from a population. 10%, when sampling without replacement, you want to make sure that your sample size is less than 10% of the population. And then the large counts condition, you want to make sure that your number of successes and number of failures, or your yeses and nos, are at least 10. Okay. And so here we have an AP exam tick. The methods we use to calculate confidence intervals in the AP stats assume that the data come from a simple random sample from the population of interest. Other type of random samples, for example, stratified cluster, might be preferable to a simple random sample in a given setting, but they require more complex calculations than the ones we're going to learn in this class. So when we are talking about an example or an exercise or AP Stats exam problem, and we refer to random sample without saying stratified, clustered, or systematic, you can assume that the sample is a simple random sample. Okay, so let's take a peek at an example here. Mr. Buckley's class wants to construct a confidence interval for P equals the proportion of red beads in his container, which includes 3,000 beads. The class's random sample of 251 beads had 107 red and 144 other beads. So we're going to check whether the conditions for constructing a confidence interval for P are met. So the first thing we want to do is check if it's random. And what I see students do a lot is they will write the condition down, random, and then just put a check mark next to it. You can't do that. You have to actually write a sentence that says the class selected a random sample of 251 beads from the container. Okay, you need to specifically state that. The next condition is the large counts. Okay, and you have to make sure that n p hat and um, n uh, n times 1 minus p hat are both greater than or equal to 10. Okay, but again, what I see students do is they'll write this general formula down and put a check mark. You can't just do that. You have to show the actual calculations. So n is the sample size. Um, so 251 is the number times the proportion, which would be 107 over 251. I mean, they just gave us that it's 107 red beads and 144 other beads, and we could say that both of those are greater than or equal to 10. Um, so we could do that, but I want to show you using the formula. So we have 251 times 107 over 251 is 107. That's greater than or equal to 10, not 107. And then 251 times 144 over 251 equals 144, and that's greater than or equal to 10 also. Sometimes in a question, they may give you, they selected 107 red beads, and they may not specifically state that you have 144 other beads, but with some simple math of just subtracting, you can figure that out. So both of those are greater than 10. And then we also have the 10% condition. Again, you cannot just say the 10% or put the 10% condition, like write it down and then just put a check mark. That is not sufficient. Okay. You need to specifically say that 251 beads is less than 0.10 times 300, which equals, or 3,000 rather, 3,000. It's less than or 300. So the 10% condition is satisfied. All right. So again, we have random, 10% in large counts. You have to thoroughly check each one and state how each one's satisfied. You can't just list the conditions themselves and put a check mark. I see students do that a lot. So be careful there. So let's talk about confidence intervals, actually, confidence intervals for a proportion. Now, a couple of things that we need to talk about when we create a confidence interval for a population proportion in this case is the margin of error. And now the margin of error of an estimate describes how far at most we expect the point estimate to vary from the population parameter. Okay, and then the critical value is a multiplier that makes the interval wide enough to have the stated capture rate. Now, on the you don't have to memorize the formula for a confidence interval because our AP exam tip here is that it's on the formula sheet. The formula for a confidence interval is included on the formula sheet provided on both sections of the AP stats exam. Okay, there's multiple formulas on the stats on the formula sheet. So the important thing is to know which one to use when and what conditions that need to be verified in order to use them, and then how to interpret the results. So the margin of error is calculated using two factors. First, the critical value, and then the standard error of the statistic. So to get the actual interval, the calculation is whatever your statistic is. In this case, we're looking at population proportions, plus or minus the critical value times the standard error of the statistic. Okay, so we're going to go through an actual example here and show you how to calculate this stuff. So before we jump into that example, let's talk about the standard error of p hat. This is an estimate of the standard deviation of the sampling distribution of p hat. So we label it with S sub p hat, and it's equal to the square root of p hat times 1 minus p hat all over n. And this is going to describe how much the sample proportion p hat typically varies from the population proportion p in repeated random samples of size n. Okay, so again, this is an example of how much the sample proportion p hat is going to typically vary. Notice it's in repeated random samples of size n. Now, some people use SE sub p hat as the notation for standard error rather than just S sub p hat. So just be aware of that in case you do see that. Now, again, the specific formula for the confidence interval for population proportion is not included on the formula sheet on both sections of the AP Stats exam. However, the formula sheet does include the general formula for the confidence interval, which is what we just stated above. In general, the confidence interval is whatever your statistic is. Typically, it's going to be a mean or a proportion times a critical value, or plus or minus the critical value times the standard error of the statistic. And the formula for the standard error of the sample proportion is going to be on there as well. Okay, so here it is. Here's how we calculate a confidence interval for a population proportion. When the conditions are met, a C% confidence interval for the unknown population proportion P is P hat, that's your sample proportion, plus or minus Z star critical value times what we have here is the standard error of P hat. Okay, where Z star is the critical value for this standard normal curve with C% of its area between negative and positive Z star. All right. So, according to a 2022 Pew Research report, 75% of US adults have read a book in the previous 12 months. This estimate was based on a random sample of 1,502 US adults. Note, the conditions for inference are met. So, this problem is telling us that the conditions for inference are met. So we're going to go right into, we don't have to verify the conditions. We're going to go right into these questions here. So we want to determine the Z star, the critical value Z star for a 99% confidence interval. So for a population proportion. So there's basically two ways that we could do this. We could use table A, or we could use technology. I'll show you how to do both of them. So using technology, first of all, we're going to go to stats, calculate, test, or excuse me, distribution right here. Second, variables for distribution. And then number three is the inverse norm. All right. And then in there, we're going to put the area that we want. Oops. Okay. So we are making a 99% confidence interval. So the proportion to the left and right, the percent of area is going to be 0.005. Because remember, you're just doing one side, and 99% is the middle 99%. So half a percent is above and half a percent is below. And when we do the inverse norm, we're just doing the one side. And then comma, the mean, which is 0, and the standard deviation, which is 1. Close that off. And then we get negative 2.5758. So we're going to use Z star equals negative 2.576 and or no, plus 2.576 if we round it there. Okay, if we use table A, we're going to get the Z star critical value of 2.58 from table A. Now, remember, when we're looking at a normal distribution, okay, here's the mean. We have 3 standard deviations above and below. And the area that we're looking for between is 99%. So this part up here and this part up down here are what we don't want. Those both, this is what I was trying to explain earlier, those both have to add up to 1%. So this would be 0.005 and this would be 0.005 or 0.5% and 0.5%. Okay, so now we want to calculate the standard error of P hat, standard error of P hat. So the S of P hat is equal to the square root of P hat times 1 minus P hat all over N. And so for our example here, that's going to be 0.75 because it says 75% of US adults. 1 minus P hat would be 0.25. And then the number in the sample would be 1,502. Okay. And this comes out to, if you punch that into the calculator, 0.011. All right. And then we want to construct a 99% confidence interval for the proportion of all US adults who have read a book in the previous 12 months. So we take our proportion, P hat, which is 0.75, plus or minus the standard error, which is 0.2576, times the standard error of the statistic, so 0.011. And this would give us 0.75 plus or minus 0.028. So our interval, now you state it in parentheses separated by a comma. So you do 0.75 minus the 0.028 and then 0.75 plus the 0.028. And you would have 0.722 and 0.778. And notice the first number is always less than the second number in your confidence interval. Now, if we were to try, we can actually calculate the confidence interval on the calculator. Okay. So here's how we do this on the calculator. So you hit not second, you hit stat um, test, and then we want to scroll down to one proportion Z interval because we have one proportion we're dealing with, the proportion that have read a book. So it's down here. And it's a Z interval, so it's this A choice here. You hit enter on that. And then it's going to ask you to enter the information. X would be the number of successes, which they didn't explicitly tell us, but if you do 1502 times 0.75, you get 1,127. Then you plug in the number in the sample. That's 1502. Then your confidence level as a decimal. In this case, we wanted to do a 99% confidence interval, so it's 0.99. And then we calculate, and it automatically gives you the confidence interval as well as p hat and the n. Okay, so you can see that this is pretty close to what we got doing it by hand. Sometimes doing it by hand with a table versus everything on the calculator may be different slightly, but they're going to be pretty close in both situations there. Now, confidence intervals, when you use the full technology approach that we just did here, they're going to be generally more accurate than the values we get from the calculations by hand. So just keep that in mind. It's not wrong to do it by hand, but your answers are going to be more accurate. So let's put everything together and talk about constructing a one sample Z interval for P using what we call the four-step process here. It rhymes, state, plan, do, conclude, kind of flows together. I don't know if that necessarily rhymes or not, but these four things you want to cover anytime you're asked to construct and interpret a confidence interval, particularly if you're doing it on the AP stats exam or in the free response section there. So these four steps, and we'll go through an example and go through all four. State the parameter you want to estimate and the confidence level. Plan. Identify the appropriate inference method and check the conditions. Do. If the conditions are met, you perform the calculations. And then conclude. Interpret your interval in the context of the problem. Alrighty. So a one sample Z interval for a proportion is a confidence interval used to estimate population proportion P. So this interval gives us a range of plausible values that we are relatively confident that a confidence interval is going to contain. The true population parameter, in this case a proportion, is going to be within that interval. Okay, so here's an example. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. We want to construct a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. And then we want to interpret the 95% confidence level. So remember, previously we talked about the distinction between interpreting a confidence interval and interpreting a confidence level. Both need to be interpreted in context of the problem. Okay, so I'm going to do some typing here when we answer these, but for constructing the 95% confidence interval, we need to do that four-step process. So the first part is to state. Okay, we're going to state what we're going to do. We want to construct a 95% confidence interval for P equals, say what it is in context of the problem. Now it's not going to be, we're not constructing a confidence interval for P hat. P hat is what we're using. That's the sample proportion. That's what we're using to approximate the true value of the population proportion. So in context, we need to say what P is, and that is the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. Okay. And that's it. Okay. That's the state step. It is a long sentence, um, and you do have to write it all out. Okay. The next step is the plan. Um, what we are doing is a one sample Z interval for a proportion. Okay. Now, you can't just say we're doing a one sample. You don't want to say we're just want to say we're doing a one sample Z interval. You don't want to say we're doing one sample for a proportion. You want to say it all. It's a one sample Z interval for a proportion. Okay. And the reason is because we're going to talk about situations where you have two samples. We're going to talk about something called a T interval later, and we're also going to talk about the situations that apply or how to do it whenever you have a mean of a population instead of a proportion. So you need to be specific here. This is a one sample Z interval for a proportion. Okay, and the word interval is important there too because we're going to talk about some other things later on. Okay, so this is we got to say what we're planning to use and then check the conditions for it before we use it. So random. Um, the so the sample was a random sample of 738 cell phone users. Um, 10%. Okay, it's reasonable to assume that 738 is less than 10% of all cell phone users. Okay, not always are you going to know the size of the population that you sampled from, but usually in the context of the problem, you can infer or assume that the 10% condition is met, and then you need to state that. So here, it's reasonable to assume that 738 randomly selected cell phone users is less than 10% of all cell phone users. Okay, large counts. Okay, so 170 is greater than or equal to 10, and 738 minus 170, um, which equals 568, is greater than or equal to 10. So the large counts condition is met there as well. So the next step we're going to do is the do step. And this is where you actually perform your calculations. So here's where I'm going to do a little bit of writing. Our p hat in this situation is 170 over 738, and that's equal to 0.23. Okay. Um, since it's a 95% confidence interval, the Z star critical value for that is 1.96. Okay. So our confidence interval is going to be 0.23 plus or minus our Z star critical value times the standard error. So that's 0.23 times 0.77 all over 738. and make sure that's all inside the square root. Simplify that a little bit, 0.23 plus or minus 0.030. And that's going to give us a confidence interval of 0.200 to 0.260. Now, if you actually go back and use technology here, you're going to get 0.200 to 0.261. Okay. And then what we want to do now is the conclude step. Don't forget the conclusion. And remember, we're going to use um, the template that we talked about previously. We are blank percent, so in this case 95% confident that the interval from 0.200 to 0.260 or 261 captures the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. Okay, and that's it, but I know it's a lot there. We can't forget part B, the second part where it says interpret the 95% confidence level. Our conclusion down here is basically interpreting the confidence interval. When we want to interpret the confidence level, that's a different interpretation. So basically, we're going to say if we were to select many random samples of 738, it has to be the same sample size because you want to compare apples to apples, essentially. Cell phone users and construct a 95% confidence interval using each sample. About 95% of the intervals would capture the true, the proportion of all cell phone users. We're just gonna copy and paste here. Of all cell phone users who would admit to walking into something or someone while talking on their cell phone. All right, so that's it for this video. Hope that was helpful to you, and reach out if you have any questions. Take care.